Hi. This is the lesson for neural network for regression.
In this lesson we will learn the introduction to regression, the introduction to neural network, activation functions, activity, TensorFlow playground, machine learning, trial and error, approach, and build the predictive model with neural network. What is regression? Regression is to predicting a continuous valued attribute associated with an object. Regression is a supervised learning method. During training, actual values are provided.
Neural networks are a set of algorithms, modeled loosely after the human brain, that are designed to recognize patterns, to cluster and classify raw data and to continuously learn and improve over time. Neural network is made up of neurons. It consists of input layer, multiple hidden layers and output layers. The simplest NN is one hidden layer.
As the name suggests, neural networks were inspired by the neural architecture of a human brain. A biological neuron has dendrites to receive signals, a cell body to process them, and an axon to send signals out to other neurons. An artificial neuron has a number of input channels, a processing stage, and one output that can fan out to multiple other artificial neurons. The weighted sum of inputs and biases feed through a nonlinear activation function to output a value to next neurons. Activation functions allow neural networks to learn complicated and nonlinear complex functional mappings between the inputs and outputs. There have been three major known activation functions. The sigmoid function curve looks like a S shape. The main reason why we use sigmoid function is because it exists between 0 to 1. It is especially used for models where we have to predict the probability as an output. Since probability of anything exists only between the range of 0 and 1, sigmoid is the right choice. Tan is also like logistic sigmoid but better. The range of the tan function is from -1 to 1. Tan is also sigmoidal, S-shaped. The advantage is that the negative inputs will be mapped strongly negative and the zero inputs will be mapped near zero in the tan graph. The tan function is mainly used classification between two classes. The relu is the most used activation function in the world right now. Since it is used in almost all the convolutional neural networks or deep learning. You can try different activation functions, sigmoid vs relu, on TensorFlow playground at URL given in the slide. Hover over the connections to check the weights.
Deep learning is a trial and error, brute force, and black box approach to learn the patterns and make predictions. The approach requires three components: neural network model, loss function, and optimizer. The learning, training, is driven by data to reduce the loss in successive iterations. The optimizer is to minimize the loss function of a model by adjusting the weights, parameters.
Mean absolute error, MAE, and mean squared error, MSE, are two of the most common metrics used to measure accuracy for continuous variables. The mean absolute error is the average of the difference between predicted and actual values in the test, for example the average prediction error. Like MAE, the MSE treats deviations in either direction the same way. One difference between MSE and MAE is that MSE will tend to punish large errors more because it squares all the errors. On the other hand, MSE is more useful if we are concerned about large errors whose consequences are much bigger than equivalent smaller ones.
What does MSE and MAE tell you? MSE tells you how close a regression line is to a set of points. MAE tells us how big of an error we can expect from the forecast on average. In this lesson, I will show you the steps of how to build a predictive regression model with neural network. This demo will covered the data preparation, model development, train the model, evaluate the model, and make the prediction. The objective of this demo is to build prediction model that predicts housing prices from a set of house features. We will use the Boston housing dataset, which is collected by the U.S. Census Service concerning housing area of Boston, Mass. It has been used extensively throughout the literature to benchmark algorithms. This data sample contained 13 attributes of houses at different locations around the Boston suburbs in the late 1970s. Targets are the median values of the houses at a location, in $. The first step that we need to do is to load the dataset. The Boston housing dataset is already available in keras. The script shows that the data is returned as two tuples representing the training and testing splits. The x_train and x_test contain the feature column, while the y_train and y_test contain the label or output column. Pre-process the data before feeding it to the network. Obviously, the data needs to be rescaled. The sklearn.preprocessing package provides several common utility functions and transformer classes to change raw feature vectors into a representation that is more suitable for the downstream estimators. StandardScaler standardizes a feature by subtracting the mean and then scaling to unit variance. Unit variance means dividing all the values by the standard deviation. First we need to fit the scaler on the training dataset. Then we call the transforms method to scale the training and testing data.
We have come to the step for building the model. The script is as provided in the slide. Notice that we only specify the input shape for the first layer. All layers later will know automatically their input shape from the previous one. This activation parameter here specifies the function we want to perform on top of the layer to calculate the output. Relu is an activation function that is used to break the linearity of the model. There are many other activation functions, but relu is one of the most popular in this kind of networks. The output layer is simply a layer with one neuron and linear activation function since we are predicting only one continuous value.
Now, let's compile the model. Keras supports other optimizers than RMSprop, and you are supposed to do a trial and error process to choose the best one for your problem. But normally RMSprop works fine with its default parameters. The loss function used is the mean squared error, MSE, which is the average squared error a point is from the mean value. Keras supports other loss functions as well as that are chosen based on the problem type. The metrics shown here has nothing to do with the model training. It's just a user-friendly value that is easier to evaluate than the main loss value. Example, an absolute value loss is easier for us to evaluate and make sense of than the squared error. To train the model, we just have to call the fit method to start training. The fit method takes both the features and the labels. The validation split indicates that the model has to keep 20% of the data as a validation set. The epochs indicate the number of iterations on the data. This build model is quite impressive. The validation loss decreased from 643 to 18. Plot the training and validation error convergence according to the epoch number. We started with an error of 20k per prediction, and went down to around 3k. This is a very acceptable error value for a housing price. Model evaluation is super easy in keras. The output values represent the loss, mean squared error, and the metrics, mean absolute error. As shown in the graph from the previous slide, the model is doing good with 3k errors per house. In this tutorial, it shows you how to build a regression model, evaluate it, and use it to predict. New data values. Build model in HDF5 data format. The hierarchical data format version 5, HDF5, is an open-source file format that supports large, complex, heterogeneous data. HDF5 uses a file directory-like structure that allows you to organize data within the file in many different structured ways, as you might do with files on your computer. You can save model into keras HDF5 format as model.save, regression.h5. In this format, keras saves everything. The weight values, the model's configuration, architecture, the optimizer configuration, the entire model using the load_model method, as shown in the slide, and load the model in TensorFlow saved model format as shown in the slide. The saved model format is a directory containing a protobuf binary and a TensorFlow checkpoint. Model weights are all the parameters, including trainable and non-trainable, of the model, which are in turn all the parameters used in the layers of the model. You can manually save and restore the load weight as shown in the slide. We have learned what is regression, neural network, activation functions, machine learning, trial and error approach, the rule of thumbs to build a model. And we had also learned how to build the predictive model with neural network.